A cable from Earth to space, 96,000 kilometers. Japan says they can build it. Every rocket launch burns $5 million of fuel, just to reach orbit. Most of the rocket is destroyed every single time. That's how it works today.
What if instead of burning a rocket, you just rode a cable straight up? That's not science fiction anymore.
Obayashi built Tokyo's tallest tower. Now they want to build into space. Their plan, a 96,000-kilometer cable, a floating port, a 2050 target. The elevator uses electricity, no fuel, no explosion, no single-use hardware. One material makes or breaks the entire plan. It hasn't been invented yet, not at scale. Shizuoka University is testing it right now, in space, on the International Space Station. That test sample is what stands between a concept and a construction site. Here is how they would build it. It starts in a shipyard. Workers plasma cut 40mm steel plate, curved, precise, massive. Each plate bent to the exact radius of a 400-meter floating ring. 24 watertight compartments, each one welded shut before the next begins. Every compartment flood tested before it leaves the yard. One leak, and the port sinks. Section by section, the ring grows, each join aligned to within 2 millimeters. Underwater welders seal the base joints. The weld must hold at sea for decades. Inside each compartment, ring frames every 2 meters. The hull can't flex or the cable mount fails. Ballast concrete poured into base cells, 48,000 tons, to keep the port from tipping.
From inside the hull, it feels like a submarine. That's exactly what it is, designed to survive the equatorial ocean for 100 years.
12 thruster pods fitted to the hull. These steer a 400-meter ring in open ocean. The deck goes on last. Prefabricated in sections, lowered, aligned, bolted, welded flush. Ballast lines run from hull to control room. Workers fit every valve, every flange by hand. Lightning conductors ring the full deck. The cable will be the tallest object on Earth. Lightning will find it. The mooring chains alone weigh 6,000 tons. Each link forged from high-strength alloy steel. The hull leaves the yard. Workers line the deck as it moves into open water for the first time. The terminal tower rises from the center of the ring, 60 meters of steel lattice, straight up. Power cables pulled through the tower legs, every circuit routed before the next system goes in. Sensors on every tower leg. If the cable vibrates, every movement measured from the first second. The climber loading dock takes shape. Guide rails, locking arms, built for a 100-ton vehicle docking at sea.
Everything built here is for one thing, to grip that cable when it comes down from orbit and never let it go.
A city lives on this platform. Desalination plant, power generation, sewage treatment, all going in simultaneously. 6 generator sets installed below deck. The port cannot lose power, ever. The laser transmitter dish assembled on deck. When the climbers ascend, power beams up from here. The cable entry seal fitted around the tower slot. Storm seas will try to flood this opening. They won't. Helideck finished on the aft section. Only way on or off in an emergency, or for regular crew change. Control room fitted out. Every screen, every panel fixed. Port operations run from here, permanently. Fall arrest rails on every walkway. Equatorial storms don't stop for the deck crew. The Earth port reaches station. Thrusters fire, chains tension. Workers watch the gauges and hold. The cable starts here. CVD reactors growing carbon nanotube fiber atom by atom. Fiber drawn off the reactor onto a collection drum. Uniform, continuous, defect-free, or it starts again. CNT fiber twisted into yarn, Hundreds of fibers combined, twisted, not just bundled, for load sharing. Yarns bound into ribbon. Heated rollers press the polymer matrix through. The ribbon takes its final form. Protective coating deposited on every surface. Without it, radiation strips the carbon bonds in months. Every section imaged under electron microscope. A gap in the coating is a gap in the protection.
20 tons of this. That's the seed cable. It weighs less than a truck. It has to hold more than a skyscraper.
Ribbon wound onto precision spools under controlled tension. One kink, and that section fails on deployment. Each spool sealed in inert gas transport canisters. Oxygen degrades the ribbon. It travels in nitrogen. At the launch facility, each canister inspected on arrival, then it goes into the clean room. Canisters mounted in the spacecraft. Deployment mechanism hand-cycled by workers. Every release tested before it goes vertical. The deployment spool, motor and brake installed. This controls how fast the ribbon falls toward the port below. Fairing closed over the cable payload. 20 tons of CNT ribbon ready to ride a rocket to orbit. Final deployment system check. Every sensor, every drive. Workers run the list line by line before handover. The rocket takes on propellant, 300 tons of liquid oxygen. Workers watch every gauge. Service arms retract. Workers clear the pad. The rocket stands alone, ready. Ignition. The cable rises on a column of fire. First stop, geostationary orbit. Separation in orbit. Thrusters fire. The spacecraft orients. Below, 36,000 kilometers of nothing. The spool starts turning. Ribbon feeds out. Down toward Earth. Up toward the counterweight above. Ground crews track the descent on radar. The ribbon is thinner than a human hair, falling 40,000 kilometers. On the port, the capture crew at stations. Days of watching. Then the ribbon enters radar range below cloud. An aircraft snags it above cloud. Workers lower it to the deck. The ribbon touches the Earth port for the first time. Workers thread the ribbon into the tensioning drums, manually, carefully, one guide roller at a time. Tension applied. The ribbon goes taut, from the Pacific Ocean to geostationary orbit, one continuous structure.
That thread disappearing into the sky above me is the longest structure humans have ever built. And it took one rocket to put it there.
Ribbon anchored to the drum clamps. Workers torque every bolt. The load cells hold steady. It's not going anywhere. The weather enclosure sealed around the ribbon entry. Salt spray will destroy CNT. Workers close it out. Monitoring instruments fitted to the anchorage. If tension changes by 1%, the control room knows immediately. Control room confirms. Ribbon stable. Port holding station. The seed cable is in place. Now it has to grow. The climbers are built in Japan. Heavy steel chassis, welded up in assembly jigs on the factory floor. Magnetic linear motor units bolted to the chassis arms. These grip the ribbon and drive the climb. Gripper rollers fitted to the motor housings. Smooth running checked by hand. Every roller, both sides. Laser receiver panels mounted to the underside. Power from the Earth port beam. No fuel, no batteries. Thermal blankets on every exposed surface. From sea level to orbit, temperature swings 400 degrees. The repair dispenser fitted to the climber's sidearm. Every climber going up carries extra ribbon and bonds it as it climbs. Cargo lock jaws fitted to the deck. These hold a 100-ton payload for 7 days. Workers cycle every jaw. Emergency brakes fitted to every gripper arm. Power failure. The brakes clamp. The climber stops. It doesn't fall. Full electrical bench test. All drives energized, all sensors reading. Every fault cleared before it touches the ribbon. The first climber loaded for sea transport. Chains on every lug. Bolts torqued. 3 weeks to the equatorial port. Climber arrives at the port. Crane swings it across from the supply ship. Guide rails catch it, and it's home. Workers thread the ribbon through the climber slot. Grippers close. The climber is on and loaded. Laser locks onto the receiver panels. Motor drives spin up. The climber grips the ribbon and starts to rise. The first climber moves, slowly at first, then steady. The ribbon holds. The cable factories run around the clock. 510 reinforcement climbers to load, starting now. Each climber carries a full spool of reinforcement ribbon. Load it, close it, send it up. Inside every ascending climber, the bonding head presses new ribbon onto the cable, layer by layer. Control room tracks every climber altitude and bond quality in real time. A weak bond. The climber stops and redoes the section. Returned climbers serviced on the dock. Worn rollers swapped. Inspection sensors calibrated. Then back on the ribbon. A satellite crosses the cable path. Port thrusters fire. The ribbon swings clear. Workers watch the crossing, then return to station. Ground crew inspect the lower ribbon by contact trolley. Every bond below cloud checked after every storm. After a lightning strike, the ground strap replaced. Workers have a spare ready every time. It's a consumable, not a catastrophe. Climber 100 loaded. The ribbon at the tower guide is already twice the original diameter. Damping masses clamped to the ribbon at calculated intervals. Stops resonance when multiple climbers run simultaneously. At year 6, factories retool for wider ribbon. The cable is strong enough now to carry the heavier spools. 300 climbers flown. Workers replace the guide rollers with wider bore versions. The cable has outgrown its own terminal. Year 14, the factory runs final thickness ribbon. The cable near completion now accepts a 100-ton load. Year 15, the first real cargo goes up. Not reinforcement ribbon, station components. The cable is strong enough. Full load test. 100 tons on the ribbon. Terminal load cells read design limits. Workers log it and clear the next climber for loading. While climbers reinforce the cable, the GEO station is being built on Earth, module by module. Modules go to orbit by rocket. The irony isn't lost. Rockets building the thing that replaces rockets. Second module docks in orbit. Latches engage. Workers in the port control room confirm the lock. 36,000 kilometers up. The gravity ring assembled on Earth in segments. When it spins in orbit, it simulates Martian gravity for the crew. Solar array trusses assembled on the ground, hinges fitted. In orbit, they unfold automatically. At GEO, construction climbers hold position on the cable. Robotic arms reach out and bolt the frame sections together. Workers climb to GEO by cable. They fit the internal life support by hand, in microgravity, working 8-day shifts. Cable guide bearings fitted through every station level. The ribbon must pass through without touching the structure. Solar arrays deployed. Panel by panel, the hinges release and lock. Station complete at GEO. Docking ports open, arrays deployed. Workers have built a city at 36,000 kilometers. The first crew returns by cable from GEO. They walk off the dock, 8 days up, 8 days down, first of thousands. The counterweight built block by block on Earth. 12,500 tons, assembled before it goes to orbit. Counterweight modules loaded on cargo climbers one by one, weight checked at the dock, every kilogram logged. Each module attached above GEO, extending the cable outward. The counterweight grows at 96,000 kilometers. Tension rises at the terminal as counterweight mass grows above. Workers monitor every kilopascal. The first passenger climber fitted out. Seats, life support, viewports. Workers fit every panel. This one carries people. Full passenger loading rehearsal at the port dock. Every step practiced until it's as fast and safe as a ship boarding. Life support consumables loaded for an 8-day climb. Workers inventory every item before the hatch closes. Final checks. Gripper alignment, power, communications. Workers run the list line by line, nothing left to chance. Day 1, through the atmosphere. Day 3, Van Allen belts. Day 8, GEO. Workers below track every meter. Port control room, every reading logged, altitude climbing, power beam holding, cabin pressure steady, all nominal. GEO station crew at the docking hatch. The climber appears below the station after 8 days. Docking arm reaches for it. Latches engage, hatch seal confirmed. The hatch opens, and for the first time a passenger walks from the cable into the station. The second climber loaded. Same checklist, same sequence. The Earth port is a terminal now, not a construction site. The port in the Pacific. The station at GEO. The counterweight above. Climbers on the ribbon. The system is alive. A satellite going to orbit. No rocket, no flame, no noise. Workers close the hatch, and it rides the cable up. $10 per kilogram to orbit, against 2,720. That number changed everything. A second port under construction, a second cable planned. One ribbon wasn't enough. A cable from ocean to orbit, built by welders, climber mechanics, ribbon workers, and control room crews. One step at a time. Every bolt tightened by a worker. 96,000 kilometers from the ground. The same tools, the same hands. 5 climbers on the ribbon at once. 5 payloads moving. The system running, as designed. A Mars crew loads at the port dock. They climb to GEO, board their ship.
Japan imagined this only on paper. We brought it to life. Subscribe for more engineering stories.